Ever pondered over the process of calculating p-values in statistical hypothesis testing? It's a crucial part of the process, as it determines the probability of obtaining a result as extreme, or even more so, than the one observed, provided the null hypothesis holds true. The smaller the p-value, the stronger the evidence there is against the null hypothesis. The specifics of p-value calculation hinge on the type of hypothesis test being conducted. However, the general procedure boils down to these steps. First, identify the test statistic. This means determining the apt test statistic for the type of hypothesis test you're conducting. For instance, a t-statistic is used for one sample and two sample t-tests, a chi-squared statistic for chi-squared tests, and a z-statistic for z-tests. Next, calculate the test statistic. This is done using the sample data and the relevant parameters of the test. Then determine the sampling distribution. This involves identifying the appropriate sampling distribution for the test statistic, representing the range of values the test statistic can take under the null hypothesis. You then need to locate the observed test statistic on the sampling distribution. This is achieved by comparing the test statistic to critical values, or by calculating the cumulative probability of the test statistic. After that, calculate the p-value. For a lower-tailed test, the p-value is the probability of obtaining a test statistic less than or equal to the observed test statistic. On the other hand, for an upper-tailed test, the p-value is the probability of obtaining a test statistic greater than or equal to the observed test statistic. For a two-tailed test, the p-value is the sum of the p-values for the lower and upper tails. Finally, interpret the p-value. Compare the p-value to the chosen significance level, denoted by alpha. If the p-value is less than or equal to alpha, the null hypothesis is rejected. Otherwise, the null hypothesis is not rejected. There are several ways to calculate p-values using statistical software. For instance, in R, the function is used for t-tests and the function for chi-squared tests. In Python, the function is used for two-sample t-tests and the function for chi-squared tests. For those who aren't familiar with statistical software, online calculators or statistical tables can be used to calculate p-values. However, it's crucial to grasp the underlying concepts of hypothesis testing and p-values before using these tools. So there you have it. A simplified step-by-step breakdown of calculating p-values. Remember, the smaller the p-value, the stronger the evidence against the null hypothesis. So the next time you're deep in statistical analysis, you'll know exactly what to do.